So, hey everyone, and welcome to this session. It's the hoarding syndrome. Collecting data is not the answer to your problems. My name is Per Sike, and I'm responsible for the digital offering at SRP. And I want to start by saying that the reason that we give this presentation today is, well, obviously that you could learn something, but it's also the case that we're in the middle of the journey ourselves. So what we'll be presenting is more of what we're doing. So it's not only theoretical, it's actually something that we're working with. So hopefully in 6 months or 12 months, we're going to be done with the journey and have some good takeaways. I assume you're in a safe environment and you know the nearest exit points. If you have any questions, then just ask them in the digital space, and I'll make sure to answer as many of them as possible. Here's the agenda. We're gonna quickly introduce you to what we do, me and my team, and that will set the scene for data hoarding and why we need to do something. I'm gonna say a few words about hoarding, the consequences, a different approach suggested by us. I hope you will learn something from it, and I hope that you will provide feedback on improvements, so maybe we will be better off with your feedback. And then we'll call it data use cases. Understanding data, where that is important. We're going to look at our process, and then we're going to end with a few conclusions and more questions if you have any. But again, just ask questions if something is unclear. So quickly about my team and what we do. We build, among other tools, we build something called SAM. And it's, well, let's say a digital assistant that you can use. I'm not sure if the slides are synced here. Can the control room double check? Okay, we build SAM. It's a digital assistant that is used by our customers to get an overview of the equipment they're buying. Could be crushers, screens, hammers, attachment tools. And we offer standard features such as fleet management. You will get a very easy overview. We can give alarms when something is about to break or is not okay. We have a pretty mature e-commerce solution where you can buy spare parts to your equipment and much more. And to make this run, we need a lot of data. Just for fleet management, we need data. So we're using a part of our data that we're collecting, but not all of it. We're collecting a large quantity of data that is just stored on a database, like so many others. We collect data because we don't know when it's going to be needed again. So in a sense, we're as guilty as anyone else for data hoarding, and that's something we want to fix. That's SAM, and that's the reason why we look at data hoarding, and we've come up with a way of doing it differently. So a few words on hoarding. I don't know if you remember, but I remember back in 2015, I think it was, when we realized that we had large data quantities in general in the world, and predictive maintenance was popularized. I mean, that's not a new technology, but the new CPUs and the computing power was, enabled us to do something with it. So we were going on about data and machine learning and how that's going to revolutionize everything in the next few years. And for some that happens, for most people that didn't happen. And now almost 10 years later, we're still discussing like data, predictive maintenance and other use cases. And depending on where you are, like if you look at different industries, then obviously we're different in maturity. If you take e-commerce on one side, they're pretty mature, I would say. I mean, maybe if you work in e-com, you might not agree, but if you compare that with construction and other industries, they're pretty mature. But all in all, a majority of our industries and companies globally aren't using the data enough or at all. And there's been recent studies conducted where we know that there is well above 50% of companies don't use data. So that's still a thing, collecting data blindly. And I will also argue that data hoarding, and this is something the future will show us, but maybe that's not a good thing at all. Maybe we shouldn't hoard data if we don't know what we're going to use it for. So that's something to think about. Maybe that's an anti-pattern. I don't have the answer, but for some companies, it's just going to be a huge cost and with very low value. So that's a bit on hoarding. And then for the consequences. First of all, like I said, there is a cost related to data hoarding. Just storing data obviously costs a lot of money, but also maintaining and organizing your data, it takes time, and that's going to be related to a cost. But then when you start working with the data, you probably have, we've collected huge quantities of data, and just understanding and making sense of the data, again, it's going to take a lot of time and it's going to be costly. And then the fourth point here is tiered pricing. Our cloud providers, they usually have different tiers. So if you just want to tinker around with something, it's very inexpensive. And then when you start using data, it's still pretty inexpensive. But when you collect large quantities of data, what they realize is that there's no way out. You're not going to migrate from one cloud vendor to another. So that's when they add a cost to the storage. So once you have large quantities of data, it's going to be very expensive of just keeping it there. And then we have GDPR and compliance. Needless to say, storing large quantities of personal data, that is, it's a complicated thing to do, and it's often related to a huge risk. And we've seen many data breaches that ended up in disaster. And again, it's a cost. Also, complying with regulations and for example, the Data Act in Europe, it's complicated. It's going to take a lot of time and resources to be sure that we're doing the right thing. And then security. In general, the more data you have, the likelier it is that someone will attack you. It doesn't matter if there is a lot of value in your data. Large quantities of data is interesting to get a hold of. And then sensitive information might or might not end up in the wrong hands. And also, the more data you have, the harder it is to secure. It's usually the case that you don't have one piece of data. You're going to, over the years, spread it out in different databases, and that makes it really hard to secure. And then the last one is something called data gravity, and it works exactly like you would expect gravity to work. If you have a large chunk of data, then that will attract more data. So it will compound and be bigger and bigger. And it will also attract services and application. It means that you're going to build your applications and services as close to this big chunk of data that is possible, which means that it's even harder to entangle and get a grip on and start working with. So you're building just a big hairy ball that is really hard to work with. So that's a few of the consequences. And now we're going to look at a different approach. And again, this is what we're in the middle of this, or maybe in the beginning of this. But this is what we've been doing. We've categorized it into three things we're going to talk about. And the first one is be bold. So that means that we are going to assume that we have enough data to start working with it. It might be that we don't have enough data, but then we have to go back and fix it. But just sitting and waiting to collect more data doesn't make sense. We have to be bold and say, you know what, we have enough data. So there is no procrastination. We're going to move forward. And not necessarily related to data. I'll explain this in a later slide, but we're going to have an outside-in perspective. Data in itself and predictive maintenance or whatever data offering you want to work with doesn't make sense if the customer isn't asking for it. So we need a different approach. And then lastly, we're going to iterate. We can start small, looking at small pieces of business value that we can deliver to our customers. And then we iterate and we improve the offering as we have data and data understanding. So this is, maybe we will release our first data feature in a few months, but then the most advanced one will be in 36 months or so. So we're being bold. We're just going to assume we have enough data, and we're going to start working with it. We're going to have outside-in perspective, and we're going to iterate. And in the next coming slides, I'll explain the 3 points in more detail. So the first one, be bold, is we're assuming that we have data. And then comes the first problem. And that is, unless you've been working with data for a long time, if you're just reading the technology newspapers, for 10 years, we've been going on about predictive maintenance and how important it is that we work with it. So it's been, in a sense, stealing the show. Everyone goes on about predictive maintenance. But the truth is that there is so much else that is much more available. And it's, I would say, better to start working with something else. And I have an example here. This is the spectrum of things that we could work with. And on the left-hand side, we can just start with some basic analytics or diagnostics. We can verify our hypotheses. We've made assumptions about our software, and with data, we can verify that's actually true. We can introduce something simple like anomaly detection. It doesn't require a lot from us, and we probably have the data. And just seeing where there is an anomaly and maybe trigger an alarm to the end user. We don't know what it is, but the end user will probably appreciate it. We can work with data mining, just understanding what's in the data. And then we have predictive maintenance and we have prescriptive maintenance. Prescriptive maintenance is the next level after predictive maintenance. It's about fine-tuning the system to avoid breakdowns. And then there is probably something more. That's the question mark that we don't understand yet, but we're going to use data for a lot of things. But we're going to start in the left-hand corner with some basic things, and then we're going to progress as we understand the data and we have the needed data. So don't be blinded by predictive maintenance. There's so much more we can do. This is our data set, and it's likely that we're not going to have all the data that's needed, or that the data is going to be incomplete. And we can use synthetic data to fix that. So if we're missing data, we can fix. We can put a band-aid on that using synthetic data. In the end, we want to have the correct data. But for trying out the different algorithms, this is a good way forward. There's a couple of things that are really positive here. And that is, we can have data that we're using, the synthetic data can be unbiased. So we can, in a sense, guarantee that we're not going to have any kind of bias because it's generated. We're not going to have a problem with privacy. We know there's not going to be any privacy information in there, any user identification number or anything. We can save money, obviously, and we can also, if you want to try out different characteristics of the data, then synthetic data is really efficient. So that's a good solution if you don't have the data needed. And then we need to just quickly talk about dark data, and that is the data you have but you don't use. And this is interesting, and based on my experience, my history, then I don't think we spend enough time understanding the data. We're very quick on just assuming things, and then we make our algorithm work, and then we push it into production. But we need to spend more time understanding the data. And I'll give you an example, and this is a trivial one, but it's a real world case example. So this is a Challenger that was launched in 1986. And I don't know if you know the history. If you know, then you know how it ended up, but I'll come to that. So this is an initiative that was delayed. It was they were under a lot of pressure. And the night before the launch, the space shuttle management was forced to make a decision if we're going to launch or not, based on a very few data points. And this is what it looked like. So on the x-axis, you have the temperature in Fahrenheit, and then on the y-axis, you have the number of incidents. So depending on temperature, you can see that it's pretty evenly distributed. And the case or the decision they had to do is 37 degrees Fahrenheit okay for us? And they decided that it was good enough. And the day after they launched the rocket, it was in the air for 1 minute approximately, and then it exploded, killing 7 people. And this is a very good example of dark data, because they chose just to look at the incidents. And afterwards, when they did a deep dive investigation, they found out that this data was also available. So this is the successful, this is where they had successful launches without incidents, and it started at 65 degrees. And when you have this data, it becomes more apparent that you shouldn't, you should probably wait until it's warmer outside, and it costs 7 people their lives. So this is one of many examples of dark data, and the takeaway here is that you need to understand your data before you make assumptions, building offering. Otherwise, you're going to build something that doesn't work. Now we're going to come to the second point, the outside-in perspective, and there is a proverb, English proverb, that says that put the cart before the horse. And that's something that I think we're very guilty of in technology. We usually come with something new and exciting technology, and we go around asking like, where is the problem? Because we have the solution. And data in many ways, one of the problems, but even more apparent one could be blockchain. We've been going on with blockchain for 10, 15 years now, and we think we have a problem that needs a solution, but I'm not sure that's the case. And we're doing the same with data. We're saying the data is the solution to everything. Like you have to work with data. So we're doing it differently. We're focusing on the end customer, and we make sure we understand their needs. And then we map it to possible data solutions. And if you find one, we start working with the data. But if there is no connection between what the customer needs and working with data, then we shouldn't do it. So far, it turns out there is a lot of need for a data offering. But this is, again, not related to data, but whenever you work with technology, make sure that you start with the customer and then you end with the technology, not the other way around. So find the business value and then solve it with technology. And then the last one is our process. And this is how we're working. If we combine everything. We start out by identifying the customer need. And then we ask ourselves, is data the solution? And that's not always the case. There are other ways of solving our customer needs. And then we ask if we have enough data. And do we understand the data? If we don't have enough data, then we can use synthetic data. And we can also start collecting the data we need. So in the future, we will have the right data. And if we understand the data or not, that's a really hard question to answer. What we do know is that we need to spend time on understanding the data. And then we have to think about where the solution should be implemented. It's not always in the cloud. It could be closer to the equipment. We implement whatever feature we're working on. We put it in dev or production. We do testing. And then we come to probably the most important step, and that is evaluate the solution. So have we built something based on data that our customers are asking for? If we can't say yes, then we've failed. But anyway, we do this in iterations. So the first iteration could be, say, anomaly detection or just analytics. And that's a way for us to get to know and understand our data and stress test it. And then in the next iteration, maybe that's in the fall, we can look at something a bit more advanced. We can start working with data mining. And then in maybe 24 months or so, we're going to have predictive maintenance included in all of this. So we do it iteratively, which makes a lot of sense. It's not involving a lot of risk. We take it step by step, and we take time to understand what we're doing. So that's the process as of today, and then we'll see how we can improve this. A few conclusions, and if you have any questions, there are 2 things. First of all, like I said, doing it this way iteratively is pretty safe. And just assuming that we have the data works really well. We have the tools to strengthen the data and add data where it's missing. I guess the one thing that is become apparent to us is that it's building an offering where we can build a revenue model is really hard because the features we're going to build over the next 12 months is not going to be strong enough to start charging it or have some kind of subscription model. So that will have to wait until we have a strong offering. So a safe way of doing it, bit frustrating because it takes time, but just going for predictive maintenance right away would probably be a failure for us. That's it. Any questions? There's a few comments in the chat. We're all building our own isolated data silo. Yes, that's another consequence of just collecting data. We're probably not going to spend time merging or thinking about, the different divisions and what data is overlapping. I mean, I totally agree. So that makes it even more complicated, but also costly. And when you start working with the data, you're going to have 2 or 3 what you consider to be the master data. Then you have to resolve whose master data is the correct one. Really good. How do you make sure that the right teams can discover and get access to the data? I mean, the team that I'm working with, we have direct access to the data. And just to comment on this one, we did 2 years ago before I joined, and we did an initiative where we used a third-party consultancy to build a data offering for us. And I know that that's often the case. That's often how we think, but I think that's a mistake, because I think that data is going to be a core competence going forward, and it would be as natural as having a project manager, tester, developer, designer in your team. You're going to need the data in your team, directly in your team. Then if that's in our team or somewhere in Sandvik, it doesn't matter, but it has to be core competence and be considered as core competence. Then sharing the data with other teams is really hard, because we already hit someone else mentioned, like there is already duplicated data. We collect data closer to the equipment. We have the SCADA system, automation system, and that's really, we're working on a strategy for how to figure out where it should be and how we share data. And sharing data is not an easy thing. So I don't have a good answer yet, except we work with it in our team and we have access, but sharing it is difficult. What is your view on keeping quality and consistency in large amounts of data when you get it from several different sources? Well, unless you work actively with it, that's not going to happen. So if you think you're setting up a data source where you can just collect data, and you think it's safe to do that over a long period of time, that's going to be a mistake. It's not going to work. You need to actively work with the data, just understanding and keeping it in the right format, or it's slowly going to deteriorate. In our case, we have people who are picky with data, and who's taking responsibility for data ownership. And I think someone should have that responsibility, even if you're just hoarding data. You can't hoard data without some kind of data policy and someone being responsible. Yes, the business case should drive data gathering and data analytics 100%. So the business we bring to the value to the customer is the only thing that matters. Everything else is like, okay, it's how we solve it, but it's really the business value here. I think we have another minute, but we're running out of time. So if you have more questions, and especially if you have input and you think you can improve our process, then that's very much welcome. So reach out, and we can have a dialogue going forward, because we want to improve this, and we can share it again and see the conclusions in 12 months or so. That's it. Thank you so much.